Hello my dear students, how are you today? Today we'll start with the second lesson in this term and we'll talk about seeing colored objects. Previously we learned about light and we knew that light is a form of energy that causes vision, and also we studied the properties of light and we learned that there are 5 properties of light: that it travels in a straight line, that it transmits through different materials, and we learn about light refraction, light reflection, and light separation. Here we will learn about the light separation. Also, we learned that the white light is consists of 7 spectrum color, and we can divide this white light by using the glass prism. So the glass prism used to separate the white light into 7 spectrum color. By mixing these spectrum color again together, they will produce the white light. So how can we see the colored object? We learned from also the properties of light, that light transmitting through different materials, that there are many types of material such as the transparent, semi-transparent, and opaque material. We have 3 types of colored object. First is the white, second is the black, the third one here are the colored objects. Starting with the white. If we have a white transparent object, what will happen to the light when it falls on this object? The white object will absorb all of the 7 spectrum color and also transmit all. Transmit means here path through, it don't reflect the light. White transparent object again absorb all of the 7 spectrum color and transmit all of the 7 spectrum color. What else? Let's continue. If we have a colored transparent object, what will happen when the light fall on it? It will absorb all of the 7 spectrum color, but it only transmit its own color. So if the object's color is yellow, for example, so it absorb all of the 7 spectrum color and only transmit its own color, and in this case it's the yellow. If we have a black transparent object or a black object, what will happen to it? It will absorb all of the white light and it will not transmit any. Absorb all of the white light. In this case, if we have an opaque object, white opaque object, what will happen to it? As we see here, it will absorb all of the white light and it reflect all. In this case, it will reflect all. Again, the white opaque object absorb all of the 7 spectrum color and reflect all. Don't mix these together. The first one, the white transparent, absorb all and transmit all. Transmit here means path through, because it's a transparent, it allow most of the light to pass through. While the opaque object, it don't allow light to pass through, so it absorb all of the 7 spectrum color and reflect all. What happens if we have a colored opaque object? Also, it will absorb all the 7 spectrum color as we see here and reflect its own color. Reflect its own color means, as we see in this picture, or the leaf here, its color is green, so of course it will absorb all of the 7 spectrum color and it will reflect its own color, and in this case its own color is what? As you see, it's green, so it will absorb all of the 7 spectrum color and reflect its own color. What about if we have a black opaque object? Also, it will absorb all of the color. This is a summary. And white opaque object, a black opaque object, and a transparent object. In the case of the white, the light fall on it is reflecting back, while in the black opaque object the light is absorbed, while in the transparent transparent white object, it transmit all of the 7 spectrum color. Seeing colored opaque object through a transparent object. What will happen when we try to see a colored opaque object through a transparent colored object? As we see here in this case, if we have a red apple, when we look at it directly, we can see it as red. Why? Because it's red, so it absorbs all of the white light and reflect its own color, because the apple of course is opaque object. While if we see the red apple here through a red glass sheet, the red glass sheet is what is transparent. Also we see it red. But what happened here? In this case, the white light fall on the red apple and it absorb all of the 7 spectrum color and reflect its own color. Its own color here, or in this case, is what is the red color or red light. When the red light fall on the red glass sheet, the red glass sheet absorb the red color and transmit it. So we can see the red apple as red. What will happen when we change the red glass sheet with green glass sheet? Also, from the beginning, the 7 spectrum color fall on the red apple, so the red apple absorb all of the 7 spectrum color and reflect its own color, and it's what? Excellent, red. The red color fall on the green glass sheet. The green glass sheet absorb the red light or red color and it don't transmit it. Why? Because the green glass sheet only transmit its own color and there is no green color in this case. So the red apple seems black. Also, by changing the green glass sheet with a blue glass sheet, as we see here, what will happen? Again, the red apple absorb all of the 7 spectrum color and reflect its own color, and in this case again it's the red light fall on the blue glass sheet. What will happen to it? Try to remember, as we said before, red color, blue glass sheet. What will happen? The blue glass sheet will absorb the red color and it will not allow it to pass through it or transmit through it. So also in this case we will see the red apple as black. What will happen if we change the glasses of sheets here into white? From the beginning, the red apple, the white light fall on it, it will absorb all of the 7 spectrum color and transmit its own color, and in this case, as we said before, it's the red. The red light fall on the white transparent glass sheet, and also in this case we will see the red apple as red. Also, by changing the glass sheet into black, we will see the red apple as black. So from this we can conclude that the opaque object seen in its gray color when you look at it through transparent object that has the same color. Okay, let's go to the next point. Mixing the colored light. We have 2 types of light. The first is called primary colored light and the second is called secondary colored light. What is meant by primary and what is meant by secondary? We will study it, each one of them. Starting with the primary color light. The primary color light, it's the light that, or it's the color that can't be produced by mixing 2 colors light. Again, the primary color light, it's the color that can't be produced by mixing 2 colors light. And we have three primary color light, and they are red, green, blue. The red, the green, and blue are the primary color. What is meant by primary? Primary, the color that can't be produced by mixing two colors light. The second type is called secondary color light. What is meant by that? Secondary color light, it's the color that can be produced by mixing two colors light. Again, the secondary color light, it's the color that can be produced by mixing two colors light. If we mix two colors light together from the primary color, it will give me the secondary color light. As in this case, we have the primary color light like the red, green, and the blue. So by mixing, starting with the red and the blue, by mixing red and the blue, they will produce the magenta. Also, by mixing the green and the blue, they will produce the cyan. And by mixing green and red, they will produce the yellow color. So the secondary color light, as we see here, are the magenta, the cyan, and the yellow. So that's it for today. Thank you for watching, and if you need anything, you can contact us by scanning the QR code and logging into any of the social media accounts, or you can contact to me directly with my WhatsApp account. Thank you for watching. See you next time, and goodbye.